Hi, my name's Steve Redpath, Trans-Euro Engineering. We're a Sitting Guild and EAL approved electrotechnical training centre. In this video I'm going to demonstrate how we carry out an earth loop impedance test on a final circuit, otherwise known as ZS. So we have our multifunction tester here, which we select to perform the earth loop impedance test, and we need to measure at the furthest point on the circuit. So this is a live test, and we carry out this test to ensure that we meet the maximum disconnection times for our protective devices. So in order to carry out this test, we need to establish for the furthest point. So in this case I'm going to demonstrate where to measure on a lighting circuit. So we have a two-way lighting circuit, and the furthest point on that will be the output to the lamp. So again, 3 leads with this meter. So we connect the earth lead to the CPC of the circuit, furthest point, and then we're going to connect across the line and neutral to the lamp in the ceiling rows, like so. We then need to energise the circuit via the circuit breaker and make sure the lights on the switch are on. So my meter is telling me we've got a live supply at this point now. So at the furthest point of the circuit, we've got earth fault loop impedance tester selected. I'm ready to test. So it's now running the test, and we have a figure of 0.88 ohms. So that is the ZS for this lighting circuit. It's two-way lighting circuit, so we just need to put the switches in the opposite position to check to see if there's any difference with the difference test position. So we're running the test, and this time it's 0.85, so negligible difference. But anyway, the highest value is recorded on the schedule of test results. So that basically completes the test. We then need to check that that value that we've recorded is less than stipulated in the wiring regs for this size of breaker, which is a B6. If the earth loop impedance that we've measured is less than the stipulated or tabulated value for this breaker, we then know that under fault conditions this device will disconnect in the required time. So that's the lighting circuit. I now wish just to demonstrate how we carry a similar test out, or the earth fault loop impedance test out, on a ring circuit. So in this case I'm going to use an adapter because we're going to be testing at the socket outlets. So in this case we use again 3 leads, and we're going to go around the ring circuit at each socket measuring the earth loop impedance. So now we're ready to energise the circuit, which is this device here. Now the difference here is our lighting circuit was not protected by an RCD, whereas now it is. Now if we were to run the test now, I'll just demonstrate. It trips the RCD. The reason being is our meter is sending a test current down the earth CPC, and this is being picked up by the RCD. So with my meter, I put it on a less sensitive no trip setting so that I can re-enable the circuit with the RCD, rerun the test, and hopefully this time the RCD won't trip. So it's now running the test. Because we're running a lower test current around the system, it will take a bit longer. So we wait for the meter, and that provides me with a ZS value of 0.72. We now then move to the next socket and repeat the test. And basically we're going to repeat the test at each socket, and the highest figure will be the one that we record on the schedule of test results. And in theory, as we go around the ring and we get further away from the consumer unit, the value should increase. As we come back around the ring nearer to the consumer unit, the value should start to decrease. So the furthest point, or the highest reading, will be the furthest point on the ring. So we continue those values, or continue those tests. So we're nearly done there. Takes a bit of a while because the meter's on a less sensitive setting, so we don't trip the RCD. So that was 0.69. Final socket, which is this one here. Again, we just run the test. So bearing in mind that if this is a spur from the ring, we have an increased impedance because of the extra cabling. So we could expect this socket, if it is a spur, to be slightly higher than the other readings. In fact, it is 0.78 ohms, which is slightly higher than these three. So it's either the furthest point on the ring, or it could even indeed be a spur off the ring. So we've completed the test. We record the highest value, and then not forgetting we need to check whether that value is less than the tabulated values for that particular breaker, taking into account any compensation that we need to take into account of temperature, otherwise known as the rule of thumb, the 0.8 factor that we need to build into that comparison. So that completes the earth fault loop impedance tests. So the ring test and the radials, the same would be the same for a radial socket. We go to the furthest point to do the measurement. In this case we have a cooker circuit, so we go to the end of that circuit, i.e. at the switch here, and do the same measurements and record the values. Okay, so that completes an earth fault loop impedance test. So if you want to see more of these videos of the different test procedures, please go to our website www.trans-euro.co.uk.